Today we're going to talk about learning target 2, which says I can find the intercepts of a function in various representations. Learning target 1 was about finding the slope. 2 is about finding the intercepts. Now the intercepts of a function are the places where the function, in this case because it's a linear function, it's a line. So the places where the line crosses each of the axes. The x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. Now if you think about what that looks like on a graph, this is the x, this is the y. The x-intercept happens when the y-coordinate is 0. For example, this point right here would be 4, 0. Any point on the x-axis has a y-coordinate of 0. So the x-intercept happens when y is 0. Any point on the y-axis has an x-coordinate of 0. So the y-intercept happens when x is 0. So in each type of function, we're looking at what happens to the function when each of the values is 0. The x-intercept happens when y is 0, and the y-intercept happens when x is 0. So let's think of a function in slope-intercept form. Let's think of y equals 2x plus 5. So in order to find the x-intercept, we're going to put 0 in for y and solve to see what x is. In order to find the y-intercept, we're going to put 0 in for x and solve to see what y is. To find each intercept, you put 0 in for the other letter and solve. So I'm going to make a line right here. This side is going to be my x-intercept. This side is going to be my y-intercept. So I have two different sides. My x-intercept, I'm going to put 0 in for y. And for my y-intercept, I'm going to put 0 in for x. So for my x-intercept, instead of y equals 2x plus 5, it's going to say 0 equals 2x plus 5. And then I solve to see what x is. So I would subtract 5 from both sides, just like I'm solving an equation here. So I have negative 5 equals 2x. Divide both sides by 2. So x equals negative 5 over 2. That's my x-intercept, which means I'm going to write it like this. When I put 0 in for y, my x-coordinate was negative 5 over 2. So this is my x-intercept. My y-intercept, I put 0 in for x. So instead of 2x plus 5, it's 2 times 0 plus 5. So that 2 times 0 is just 0 plus 5, so y is 5. So that tells me that when I put 0 in for x, my y value is 5. So that is my y-intercept. Now let's move on to point-slope form. Point-slope form is a little bit trickier. We'll just say the function y plus 3 equals a slope x minus 4. This is an example of a function in point-slope form. So this is something that you'll just be given. You'll be given an equation, and then you'll be asked, what are the x and y intercepts? Where does this function cross the x-axis and y-axis? So again, to figure that out, we can do our x-intercept, which is really plugging 0 in for y, and then solving. So we have 0 plus 3 equals 2x minus 4. So I'm just putting in 0 in for y to see what x is, and that will be my x-intercept. So 0 plus 3 is just 3. Then I can distribute that, so I have 2x minus 8. Now I just solve for x. So I add 8 to both sides. 11 equals 2x. Divide both sides by 2. So x is 5.5. If you do 11 divided by 2 in your calculator, it equals 5.5. So the x-intercept says when I put 0 in for y, my x value is 5.5. For the y-intercept, I'm going to go the other way, and I'm going to put 0 in for x. So I have y plus 3 equals 2 times 0 minus 4. So I just rewrote the function, but with a 0 in for x. Now I have y plus 3 equals 2, and then if I simplify what's in parentheses, 0 minus 4 is just negative 4. So y plus 3 equals 2 times negative 4 is negative 8. Subtract 3 from both sides, so y equals negative 11. So my intercept, when I put 0 in for x, the y value is negative 11. My x-intercept is 5.5, and my y-intercept is negative 11. Standard form is the easiest for solving for intercepts. Each function has a strength. Slope-intercept form is nice when you have a slope and it's easy for seeing what the y-intercept is, because the y-intercept is always just whatever number is out here. Because when you plug 0 in for x, that goes away. Point-slope form is nice for graphing things. Standard form is nice for finding the two intercepts, and here's why. Let's just say we have this function, 2x minus, 5x equals 20. I just made that up. So to find the x-intercept, we put 0 in for y. Oh, sorry, that should be a y right there. 2x minus 5y equals 20, because standard form has an x and a y. So if I have this function in standard form, if I want the x-intercept, I put 0 in for y, because the x-intercept happens when y is 0. So I rewrite this, 2x minus 5 times 0 equals 20. Well, that just goes away, and I have 2x equals 20. Divide both sides by 2, so x is 10. So my x-intercept is 10 when y is 0. For my y-intercept, I put 0 in for x. Now I have 2 times 0 minus 5y equals 20. Well, this time this disappears. So I really just have negative 5y equals 20. If I divide both sides by negative 5 like that, y is negative 4. So when I put 0 in for x, the y-intercept is negative 4. Standard form is the nicest for finding the intercepts, because when you put 0 in for each of these, it just disappears. So if I want to find the x-intercept, that just goes away. So I'm really just solving 2x equals 20 and x is 10. If I want to find the y-intercept, I put 0 in for x, and that one goes away. So I'm really just solving negative 5y equals 20. So negative 5 times negative 4 equals 20. So it's right down there. Standard form is the nicest for intercepts. Graphing is also really nice, because the intercepts happen when the line crosses each axis. This is because the x-intercept happens when y is 0, which is on the x-axis, and the y-intercept happens when x is 0, which is on the y-axis. So here the x-intercept is right there, which is at the point 1, 2, 3, 4. So it's at 4, 0. The y-intercept is at 1, 2, positive 3. So it's at that point right there. For this one, the x-intercept is out here at 1, 2, 3, 4. So this one's the same. The y-intercept is at a positive 3. Here, the x-intercept is at 1, 2, 4 again. These are all at 4. The y-intercept this time is at negative 3. Okay. Here, the x-intercept is at 1, so the ordered pair there is 1, 0. And the y-intercept is at -2, and the ordered pair right there is 0, -2. So graphs are also really nice for intercepts. And tables are really nice too, because remember that each intercept happens when the other variable is 0. So in this one, the x-intercept happens when y is 0. And remember that f of x is really just y. So if you want to put a little y right there to remind you, that's not a bad idea. So the x-intercept happens when y is 0. Well, that's right here. Y is 0, which means that's your x-intercept. The y-intercept happens when x is 0, which is right there. So it's 0, -2. The x-intercept over here happens when y is 0, because the intercepts happen when the other variable is 0. So the x-intercept is right there when y is 0, -3, 0. And the y-intercept happens when x is 0, which is there, 0, 21. Here, the x-intercept happens when y is 0, which is here. And the y-intercept happens when x is 0, except there is no x. So what we can do is we can count back. If I kind of bring this going up here, 1, 0, I can extend my table going backwards. And here I'm counting by, I'm subtracting 4 going backwards. So 8, 4, 0, -4. If I subtract 4 more, I'd be at -8, and 4 more, I'd be at -12. So really, it's right there. Sometimes you just have to extend the table a little bit. Or, if that's difficult, you could write an equation for the table and then solve it like this. But we'll talk about that later. So that is how you find the intercepts. Notice that in every single case, the x-intercept has a y that's 0. Here the x-intercepts all have 0 for y. Here the x-intercepts all have 0 for y. Notice that the y-intercepts all have a 0 in the x spot. That will always be the case. And that is how you find the intercepts of linear functions that are in equation form, graph form, and table form.